Time. Hello, welcome everyone to SCITT. Welcome to Dublin and 121. Oh, we already took down the QR code. I was just going to tell them, scan the QR code. Go to the mic, scan the QR code, or at the back of the room, the QR code if you haven't already. Register for the room. Welcome to SCITT, and then I'm going to let you.
Okay. Thank you. So, yep, welcome everybody. As ever, we're halfway through the week. You should know this, but every meeting that we have and every individual working group session that we have at the meeting is held under the rules of the Notewell. There's a little sneaky preview. We had some feedback, or rather the broader IETF had some feedback from last time to be a bit more careful about this, be a bit more clear about when we present the Notewell and how often you have to see it and whether people have to actively acknowledge it. And one of the bits of feedback there was to not just blow by it and assume everybody knows what they're doing. So please, if you do not understand the rules of your participation and contribution and the Notewell, please do ask, because it's super important. Also, note really well how we conduct these meetings. Again, if you're new here, halfway through the week, you probably will have observed by now that we have a nice, polite and collegiate system of raising hands, coming to the microphone, respectfully addressing each other's points and comments, and generally being nice and excellent to each other. We like that, works well in my experience. But if you do feel like somebody hasn't been excellent to you, there are ways of you to address that with, at the furthest resort, the ombuds people. Now, so as Chris already said, you can scan the QR code to register your attendance here. If you don't fancy doing that, you can just log in with the on-site tool in MeetEcho. This is not really new info anymore. It's about 3 IETFs old, but relatively modern interface on MeetEcho. You click the little telephone icon, and it just gives you a very, very light client that registers you, and you can see the queue and access the chat. Please don't join with the full client, because it ends up echoing in the room. We don't want that. And finally, we all love people who participate, and we all love cute hedgehogs. Do we have volunteers for note taking? Thank you, Mike and Steve. Okay, yeah. So Steve, yeah. So Mike Prorock, thank you very much, and Steve Lesker when you're not presenting. That'd be fantastic. Thank you. Okay, so here's the agenda. Any agenda bashing before we rip through this? Looks like a no, thank you. So, well, yeah, this is the agenda. It's been posted for a while, so it shouldn't be a surprise. So unless there's any questions on that, I will invite, I think, is it Henk? Yeah, Henk, to give us the overview. No.
I think you have to
Oh,
put
you
it
have to plug into my machine?
That's right.
Oh, interesting. Let's see if that works. And how many viruses I get from it.
Excellent. Welcome everybody to this SCITT session. I'm Henk. I can click. Okay. I'm Henk, and I will give you a quick recap overview about the supply chain integrity, transparency, and trust work we're doing here. So, oh, this is actually, I can't read that well.
Do you want this one?
Okay, yeah, I actually can see that better. But I know the charter. So we will define interoperable building blocks that enable you to create some transparency statements and things that are for standalone systems, like you're starting from scratch and you want to have a system that's a transparency service that will enable be by our building blocks here. If you have an existing system, like I don't know, a data store, or maybe even a confidential ledger or something like that, we can even make our building blocks in a way that they can be added on to existing systems. The base line that we are doing here right now is the software supply chain use case. That's not so super surprising because we on the IETF have a lot to do with software. But the concept is that also when we have enough experience on that use case, that we can try to recharter and maybe get another use case for the supply chain into the charter text. There's a set of documents that exists here. You can, of course, track them on the data tracker. Most of all, we started with the architecture document. That has been quite a ride. So at first it was, it was a little bit over detailed and everything was in there. That's a good start. But at some point we realized nothing here belongs into all, not all things belong to the same document. So and in the spirit and the of the IETF, we even facilitated other working groups. So one decision here in the SCITT architecture is to use COSI as I want to say integrity and authenticity envelope. So some of this work we are not doing here. We rely on the COSI working group to do, for example, the receipt work for the architecture. I'm not going into that detail right now because that is for other people to explain later. We have other, want to say, profiles for the receipt already. I think there's a CCF profile that I might talk about in COSI at the end of the week. And also there's a mountain range profile that I have no idea who will talk about that. But then there's important thing for these kind of append-only ledgers that we rely on. Typically, they're called verifiable data structure as defined in COSI working group. And sometimes you do not want to save all the statements content in this append-only ledger, and then you just have to detach something. And therefore, the COSI working group is also working on the hash envelope internet draft, which enables you to have detached payloads and just a hash envelope. Coming from here, there are users. There's a kind of a process how to use a SCITT interoperable system. Typically, you have something to say. And then you are an issuer taking on that role and state it. That's a statement. Typically, these statements are about artifacts in our use case. I just explained before. It's a software artifact. So you can say something about your software artifact. And what you say and how you say it is opaque to the SCITT solution. In the end, it is important that it is signed. Again, we were having this one strict requirement that it's signed by COSI. And that's what this envelope here stands for. Having done that, you have this envelope and you can basically put it into the transparency service. A transparency service is basically the software that runs the append-only log. I think it is called on this slide, if I can't read it right, an e-notary, which actually is a good analogy because a notary typically watches what you do. Everybody is in the room, everybody signs the things, and then whatever you signed, you take with you again. So the contract, for example, is not put into the store, you take it home. But there is a statement at the notary that is relevant to the existence of all of it, and that is literally the analogy of the transparency service. These statements stay there, and they are append only, and they can't be taken back. If you have to append or retract something or revoke something, you have to make another statement that refers to the previous one. You can't just take it out. That's the point of the transparency and in the end of the accountability and the auditability. That's, I think, why there is a relying party auditor text here on the slide, I think. Sorry again, short-sighted. In this context of COSI, we are, of course, using CDDL to describe all that. And COSI has two headers. Most importantly, in this case here, we see the protected header. There are typical things, and they are like you have algorithms that you are used to sign with and such. I think very important to note is that we are using the CWT_claims label here. It's a different RFC. It's basically the reuse of CWT registered claims from IANA registry in a specific map. Why are we doing that? Because we want to capture information like issuer and subject, as you can see on the box on the right, the smaller one. And these things are already defined. So we were discussing something like a feed before. That is basically the traceability of statements. I just was talking about you can't take something back. You have to issue another statement that takes it back, so to speak. These trace paths can be facilitated by CWT claims in the protected header, essentially. The rest of the protected header is typical cozy stuff, so I'm not going into all of it. But there is one thing I want to highlight, and that is the, I think the X5T, it must be in there. Yeah, it's the X5T. So that is the hash of the public key that is signing the thing, because sometimes you want to have a certification path back to the trust anchor. And I think the next slide introduces that. No, it doesn't. Here we go. And that can be very big. So a certification path can be pretty long. We are talking about small cozy receipts. That's the idea. It's scalable on multiple levels. It can be presented by small things like IoT devices. So sometimes you might not want to have the certification path inside that receipt. So it's an optional thing. And the must is that you have to at least the leave statement, the X5T, that is in the protected header. And you can have in protected header the corresponding certification path. If you know where to get it, and that's implementation specific, that's also, of course, possible. All of these things are optional in the CDDL. That might sound weird because I just said you must have at least a thumbprint of the leaf in the protected header. We are not stuck with X509. We are using X509 because it's everywhere. And just using something exotic or esoteric as a starting point is very off-putting. There was some discussions about other things coming from W3C. We were dropping that. We are falling back to X509, but we are still hopeful that we are not stuck with one identity management infrastructure. We want to provide identity infrastructure agility. And that is why this is an optional item. But when you read the text, you will actually see you must have one type. And our go-to type that we start with is X509 MPKX. So that's basically the summary of the technical part. Now I have to step forward again a little bit. My eyesight really did not get better in this. Yeah, I will do it like Carsten. So, okay, I see. So basically, this is coming back to our use cases. You want to see information in that ledger that we're talking about here. And that's really easy because there's an ordering, of course, to the statement. And so in order to find related statements, you have to basically go through some stuff. So you can save all the receipts you retrieve from the transparency service while doing a registration process. So it's like your tax thing. Like if you put all your receipts in the shoebox at the end of the year, you basically know what you did as a transaction over the year. You can also go back to the transparency service and replay all of that. So there are multiple ways to do that, but saving your receipts saves you time. It's also a good thing for your auditor. So if you want to have a very, very busy auditor, you can just give him your shoebox and make him test the audit trail. Or you can go back to the transparency service and maybe have a API for that. That is basically how we also want to address the software supply use case, because software artifacts will have updates, there will be vulnerabilities, and there will be new versions. So these update streams basically are captured in that, and there will require some insight into the statement, which typically is opaque. So We don't want to force anybody to use a certain type of SBOM or a certain type of vulnerability information, but I think it's very important to note that we at least hint at the format, the media type, in this case, the content format of the message itself. Which is just what I just said. Sorry, I was going ahead a little bit. Yeah, so the content types are there, but it doesn't really tell you the semantics. So when you build a system with SCITT, and if you want to dig down into the replay, if you want to check your receipts, it is useful for the system that uses SCITT to understand, or at least to partially understand, what the actual semantics or content of the payload is. If that is possible, then you can base a lot of trust decision on such a transparency service, because you can then understand who did what when. Again, your notary would tell you. In this case, the transparency service will tell you. And I think that's my summary. I hope that I did not leave something out that was important, but if that is the case, that will be in the news.
Thank you, Henk.
Sure. Hope you brought glasses.
Yeah.
Hi, I'm Ori Steele, and I'm going to be talking to you about transparency in the news. This will be my first time seeing these slides, so hopefully you enjoy this episode of Pecha Kucha. All right, so I wanted to, we wanted to talk about some recent transparency activity, which is, related to the transparency work we've been working on in SCITT. So just for some background, SCITT started in 2022. We've been building on the experience developed through the deployment of certificate transparency and some of the early work on key and binary transparency that's happened in the open source community. There's been a number of developments in this space since we started this work, and the main sort of intention behind SCITT to sort of differentiate it from some of these other approaches. If you think about certificate transparency, it's a transparency log for proving inclusion of one specific media type, the certificate media types, right? There are other transparency logs that want to store just a specific public key format or just a specific type of binary, for example. So I'd like to think about SCITT as a system where you can decide what kind of content should go into your transparency service. And if you think about SCITT like that, you'll see SCITT-like things emerging in the news all around us. All right, so another really interesting thing that's been happening has been the work that's been happening in the transparency dev community and the recent transparency dev summit. So this is a kind of coming together of a number of different initiatives regarding transparency, in particular, a lot of the open source development in the Go ecosystem, building on the binary Merkle tree implementations that were developed to support SCITT, and then starting to think about, okay, we have a Merkle tree. It's maybe implemented pretty efficiently in Go. We can use this Merkle tree structure for some other use cases that aren't just SCITT. Where might we start to see these Merkle trees showing up in other parts of the Go ecosystem? And in particular, what are some of the challenges that SCITT faced, and how has open source technology kind of advanced to address some of those challenges? So the transparency dev, community Slack is a great community, and there's lots of discussion about initiatives there. There's been the executive order 14110 and the OMB memo regarding data provenance, the NTIA AI accountability policy report, SP 800-21A 218. I'm not going to read numbers to you. Essentially, lots of governments and government policy document initiatives have been really interested in this topic of transparency. And that's part of the sort of understanding the risks associated with critical infrastructure is to think about the ingredients that go into products that support critical infrastructure, or they're part of provisioning critical infrastructure. you kind of want to know where those ingredients are coming from, what certifications are associated with them. Maybe they're bought and resold, maybe they're modified, and it could be improved, or could be other problems that were introduced as part of that. So a lot of people think of the supply chain as like a literal chain, like a linear thing. It's not. It's a value network. It goes in many different directions. I like to call it a hypergraph when I want to use fancy graph terminology, but that complicated value network data structure is an expression of the relationships between the producers and consumers that collaborate to create our digital infrastructure. And that digital infrastructure is what supports a lot of the software that we rely on all the time, and it controls a lot of the physical infrastructure that we rely on. So there's this blending of sort of digital infrastructure and physical infrastructure when you think about enabling automation and policy configuration, some of these challenges. And that's part of why you see transparency show up in some of these other places in the news. The Linux Foundation has also highlighted the importance of open source software in development of transparency in the OSS European keynote, the FCC guide on cybersecurity labeling and IoT. And there's a number of implementers who are starting to stand up and look at deployments for supply chain transparency based on SCITT. I think this is kind of self-explaining. Certificate transparency has recently won this award. It's somewhat of a mature technology at this point. The deployment of SCITT has been sort of impressive, but at the same time, as I mentioned, there have been a lot of lessons learned in terms of managing the logs. In particular, distributing the logs has become a really interesting problem that folks are looking at new solutions to. So here's just a couple snapshots of transparency in the news, and in particular, key transparency, which I should mention, there is a separate working group, which you may be interested in following the work that's going on there in the IETF, the Key Trans Working Group. And just as a quick aside, what's interesting about Key Trans at IETF is that they're looking at a new log structure, new transparency log structure that has some new proof types that are different than the log structure that we're relying on for certificate transparency in the IETF. And SCITT, the way that it was built, was specifically from the beginning, it was designed to support new logs that might come about in the future. So one of the things I'm really excited about is if and when Key Transparency finishes their documents and publishes a new log structure, and these new proof types become available, how can we use the SCITT envelopes that we've built to support those new logs in COSI? Now, outside of the IETF process, which, as you all know, moves incredibly fast, open source developers have been already tackling some of these challenges. So, for example, the recent announcement regarding Cloudflare and verifying the integrity of the WhatsApp transparency logs is a really interesting example of these ecosystems that form around transparency. Transparency is a property you build into systems, and usually it's because you have a party that's providing a critical service where you want some kind of accountability for how they're managing that service. And so that party can partner with another reputable party to prove their compliance and correctness for their infrastructure that they're providing without revealing sensitive information to that auditor or partner. There's different terms for this. Some people call it, witnessing. Other people call it, an auditing role or a monitoring role. And these are just a couple examples from the recent news around this. Next.
Yeah, my meeting.
I've got it. All right.
You're also getting bounced.
Yeah.
All right. Me too.
I think we're back.
We're both bounced.
Oh, you're both gone. I'm up here by myself. All right. This is a large amount of text. There's I guess I want to come to the sort of one piece at the bottom, which I definitely recognize, which is VCons. They're another kind of interesting object that you might want to store in a transparency log. And you can start to see SCITT escaping its working group within the IETF as people learn about it and they think, how can I apply SCITT to my use case? Maybe I'm thinking about adding transparency someplace that, we need transparency. The certificate transparency infrastructure that we have from RFC 6962 and 9162 is maybe not a perfect fit for my protocol, but SCITT is built to sort of be a fundamental building block, so it fits really well with other protocols, which is sort of dangerous. So you'd be careful about where you provide transparency, but I think the fact that people within the IETF are seeing how they can apply SCITT is great evidence that we've designed it somewhat well.
Yeah.
All right, that's it. Are there any questions while I'm up here, from community around recent activity, or for the recent, announcements? I didn't speak to these other cases, the Microsoft case. I think this last one's from Apple. If anyone in the room wants to comment on these other instances of transparency in the news, I'm happy to have a quick chat as long as I'm not over time.
You are not yet. Mike Burrock.
Yeah, I'll just, Mike Burrock here. Thanks, Ori, for covering this stuff comprehensively since you had so much time to prepare and review. I'd note definitely some interesting stuff going on that I think is showing some of the direction we're going to see. So, broader in the industry, particularly your second note around Microsoft supply chain transparency, because it's highlighting something that I, in one of my hats, wear as kind of a lecture on cybersecurity and critical infrastructure for nation state leaders and fun things like that. And increasingly, we're looking at that intersection of the software supply chain on critical infrastructure deployed hardware, whether this is, cell towers, pump controls on canals, and all sorts of things that people forget about that turn out to be really important if there's a problem. So being able to use SCITT and talk about SCITT as a good open way that provides us this ability to interoperate, even if your vendor changes out behind the scenes under the hood, has been a really important thing. We have also directly, in kind of my day job, working on various aspects of supply chain, been able to leverage SCITT directly for audit trails and logging of evidence related to transparency in physical real world supply chains, and have actually been able to use that in regulatory actions, like to release customs holds and things like that, we didn't have a clear path around this before. So we're finding a huge amount of use that we're now starting to see come out more and more in the news. And I think that's a good thing, but it's all frankly possible because we now have a standards thing to point at, which we didn't have before, right? People were just doing these ad hoc things before. So thanks for covering this stuff.
Thanks. I love your points about the general applicability of SCITT. And I just want to be, extra clear. This slide shows, SCITT in the middle, but these other transparency initiatives, might not be using the specific ledgers that we've requested registration with AANA, or the specific message formats. They're just general examples that the industry is looking at transparency, and we are chartered to focus on software supply chain here.
Great.
So another.
Thanks, Ori.
Is a question in the queue? It's up to you. You want to?
Yeah. Hello, Lun from Huawei Research and Development. So my question is, I think the transparency, I'm kind of new here. So
Welcome.
I think the transparency service is very good. But I think many of the features is very similar to the distributed ledger or system, like something like the Hyperledger. So I wonder, do we consider some blockchain use cases for the transparency service, such as do we consider to put our transparency services to a distributed system, or have a consensus-based verification for the artifacts? Do we consider to also to cooperate with that blockchain community or SDOs? Thank you.
Thank you for your question, and welcome to the IETF. I think so. First, I would say take a look at the secure asset transfer protocol work within the IETF. So it's another IETF working group in a different area than we're in, but they're looking at a lot of these same physical supply chain scenarios and distributed ledger technology, and in particular gateways between different value networks is a thing that's very much within their charter in terms of managing transfers between networks that manage value. There is a small technology overlap between these transparency log services, which are, cryptographically integrity protected, append-only data structure that supports like proofs, like proof of inclusion, or advanced versions might even support proofs of non-inclusion or proofs of consistency, these other kinds of proof types. You also see these Merkle tree structures show up in distributed ledger implementations, in the full client implementations that are synchronizing state, those kinds of things. So there's a technology overlap to some degree. And if you wanted, with the way that we built the SCITT architecture, the ledger infrastructure itself is we're requesting a registry be created for different types of ledgers. And the first one we've added to that registry is the ledger type that is the binary Merkle tree with SHA-256, the one that supports the certificate transparency ledger. But as you saw in the earlier slide where you're seeing these other drafts that are kind of connected to the ecosystem, there are already two other ledger profiles that are sort of describing a different storage mechanism, one for CCF and one for Merkle mountain ranges. And if you wanted to, you could read those documents and think about, is there another ledger that can do, integrity protection, append only, that has these proof types? If you can figure out a way to describe that ledger such that it could be registered as a profile, those documents might be interesting to take a look at.
Okay, thank you.
I'm just going to quickly go from chat. AJ asked, so what do these transparency in the news mean for work in the working group?
So that's a pointed question, AJ.
Yes.
I think they're on the edge of the kind of thing we would usually put on a slide at the IETF. In the center, you can see, one of these is news about the specific work that we're doing here. But on the left and right, you're seeing general use of transparency in the industry. This is a pretty packed room. I'm glad to see there's so many people who are interested in transparency here. What we wanted to do by kind of highlighting that this transparency initiatives exist outside of the IETF is to say, we're working on, proposed standards for transparency inside the IETF, but we recognize that people are working on transparency outside of the IETF. They're doing it in open source. They're building different systems. And if, for example, if some of these services see something in our proposed standards that's useful, that would be great. If you're reading these and you see something that is useful that might be worth, taking a look at how could it fit into the SCITT architecture or one of these profiles. The goal here is to sort of recognize that we're not doing transparency work in a bubble. The transparency is a phenomenon in the industry for software that's emerging. And like Mike Perrock pointed out, transparency isn't just only relevant to software, despite that we are very much chartered to only look at software at this point in time. So I wanted to kind of make you aware of some of the other transparency initiatives that are happening in the community so that, if you're interested in them, you can follow up with them on your own time. And if you learn something interesting and you want to bring it back to the IETF or you want to write a draft, you have some broader context around what's happening in the transparency ecosystem.
Perfect. Well, thank you. Steve Lasker to the mic.
Hello, so Steve Lasker with Data Trails, and we'll talk about what we've been working on since last IETF. So mostly it's been around polishing up the architecture. And as you can see, we've had quite a lot. In fact, a big thank you to Hannes. On the way to the event last time, he had put in a bunch of issues and he actually wrote them on paper and then typed them in afterwards. So I really want to make sure. And it took us a bit to go through all that polish. the reality is a lot of it was polished. Like we didn't really have to fundamentally do stuff to change the direction. And it was around polishing some of the changes and the course corrections and the trimming that we had done that Hank had talked about earlier on. So all of these, and that's, we put them as links so you can drill into them. And, you know, we even cleaned out, there was much more than this. This is kind of cleaning up to the ones that are more highlighting, if you will. Everything from the analogies between the RFC for the CT stuff we were just talking about. I don't know, what are some other decent ones in here? Formats of CDDL to make sure we're actually conveying. We did find that over usage with all the text that's in the doc, we tend to scroll to the highlighted sections of CDDL and EDN. And so we wanted to make sure those reflected a good amount of detail there. And Hannes is going to interrupt me to see if I've actually got them all. Go ahead.
No. I just want to say like really big thanks that you like took my feedback so seriously. And I should also be an encouragement to others in the room, because I, after some time, reread the document, noticed things here and there, inconsistencies, and nothing big, but I thought it would be useful to share that feedback and typed it in. And so if others who look through it and notice also something, this is definitely a group of authors and who really take feedback seriously. So this is not, I'm saying that because it's not always the way how things work.
And again, thank you. And it did take us a while because we really, you know, we know how detailed our IETF docs can be. So we wanted to make sure it kind of represented that detail. So that's mostly it for that big long list. And then, you know, as we've been factoring out, and I don't want to recap this too much because Ori's already talked about this quite a bit, and Hank as well, is that we've started to get the other profiles for the other Merkle or other ledger formats. So these will both be presented I believe they'll both presented on Friday at the COSI session. So we won't drill into these two details here, but the fact that it has this flexibility is the purpose. And lastly, so even back to the diagram is 1,000 words, which is probably about what's in the doc. We've been iterating on this quite a bit as well. And Thibaut, who's a new contributor to the group at the hackathon, had noticed that the diagram didn't necessarily reflect some of the terminologies, so made a last minute PR. We didn't actually merge this in yet to the doc because it's really isolated this. We wanted to make sure we had room for more feedback. But it was related to assigning roles to the bottom sections for when you verify transparent statements and collecting receipts and so forth. And even at the top, we had been going back and forth between issuer and credentials and some other terminology we'd been using. So we've been cleaning that up quite a bit. The diagram, what's interesting about the diagram, and this isn't a change, it was just a reinforcement of it, is the idea is that a signed statement, and Ned asked this a little bit, it was kind of teasing into this with his question on Zulip, was a signed statement is something that's done prior to ever coming to the transparency service. So you're creating this statement, you're signing it, you're creating that integrity protection around the to be signed bytes, and then it's submitted to the transparency service. And it gets submitted there at the top where you can see the first one to the transparency service. It returns a receipt. We don't, from a SCITT draft perspective, we do not actually return the signed statement. It was submitted. We don't even talk about how it might be persisted. That's really up to a particular transparency service. I don't believe, Roy will probably correct me, but I don't believe MAPI actually talks about anything to do with storage. It's about how do you submit a mail message, and the storage and all those details around how mail servers work are what makes that product. But the interoperability is defined. And that's what we've really focused on here. So a receipt gets returned in one of the formats that we were just talking about in the ledger formats or the receipt formats. And then you can actually, when you staple that signed statement with the receipt, that's what makes the transparent statement. And that's also done outside of the service. If you want to re-register that transparent statement with the receipt on the transparency service, you can do that. You can also take the same Stein statement and register it on multiple transparency services, if you will. So if you're taking something, I'll pick some picking on Roy. If you take a transparent sign statement that Microsoft has issued, I might want to bring it into my company's environment because I want to be able to have all the information that we depend on in that company within our own network and in our own storage. So we can take that signed statement and re-register it on that company's transparency service as well. And then it gets another receipt. So a transparent statement can actually have multiple receipts. Sorry, a signed statement can have multiple receipts. So you have a transparent statement and it's got the collection of receipts in it. So that's what we're reflecting here. And that's because we've had questions, why are there double boxes in that section and not others? And that was it. That was it. Any questions on the diagram or anything, some of the progress we've made? Okay, great. Thank you.
Okay, so at this point, I wasn't wearing a hat, but I take off my chair hat. Although, hello, it's too low. Steve, grow. Sorry, that wasn't in the spirit of the note very well. I apologize. So yeah, there's no better way to make sure that the document authors are making good progress than to try to implement the thing. So I'm going to present Scrappy, which is the other work product of the group. So we have the architecture, and then we have the reference API. As a reminder, in case anybody didn't know, it's a very, very simple API definition that allows you to access the critical interoperable parts of the SCITT architecture. So how do we take this interoperable input in the form of a cozy sign-one message, sign statement, get back a receipt that Steve just mentioned, and manage the very minimal set of operations and configuration around that. So last time, for those who were here last time, we proved that this sort of basic thing works. We got end-to-end statement registration through to commitment on a ledger. And for the questioner earlier, in fact, this one was done on a blockchain-based ledger, in case you're interested. And then got a receipt at the end with multiple implementations and multiple companies involved and stuff. So you might imagine that we're done, right? But maybe actually not. So there's quite a few issues open in the GitHub. If you go to it, in fact, since these slides were written, there's 2 more. So I think that brings us up to 23. But it's not nearly as bad as it looks. So roughly half of them are already subject to PRs. Most of what's left are pretty small in the opinions of the people looking at this stuff. And so there's only really a handful of things that will require any sort of reasonable discussion and potentially lead to any great amount of work. And it's worth noting that none of those have any bearing on the actual architecture. There's no risk that the architecture document is going to get affected by this. It's just how we make it practical for different operating environments, operating programming languages and stuff like that. So very briefly, I want to spend more time on the questioning one, so I'm going to rush through the others. So the stuff that's already in PR falls broadly into 2 camps. There's a CBOR conversion. I'll talk about that more in the hackathon section in a second. But you know, basically everything's going fine. We had issues to track it, but whatever. The only interesting one to raise, because it's been a discussion in various places, is we went back and forth on whether to do 9457 problem details objects and invent a CBOR encoding for it, or whether to use the specific constrained problem details object from RFC 9220. We ended up with 9220. It's working, so you know, unless anybody really cares, then we'll leave that there. And all of the rest is about just tidying up things with long-running registrations. You know, it's a pretty much a myth that you'll find any serious distributed decentralized ledger system that can commit and return you something in the sort of milliseconds that an API requires. So we had a kind of 2 approaches running in parallel, and we've tidied those up. The small ones mostly are related to document flow. Hat tip to, I should also mention hat tip to Christian Amsus for the problem details thing, because I was totally scared of it and didn't want to do it. And he sat down with me for a moment at the hackathon, and now it's working. So that was good. And similarly, Michael Richardson has had a couple of passes through the document, has very valid comments on the flow. So a lot of the small issues, they're super important, but they're all relatively small things just to add clarity. And the only one in there that maybe requires discussion among the group is a proposal to remove the resolve statement endpoint. You can already resolve signed statement, and then the client can just strip off the signature. That feels much more kind of philosophically right. So speak now or forever hold your peace, I suppose, or join us on the GitHub and have a look at the PR for that. But that's the only one that's interesting. So here are the ones that are actually for discussion in the working group that we think are probably interesting in terms of getting finished. So there's been a lot of discussion on identifiers and what's the meaning and what are the semantics. How do you derive the identifiers that come back from these various different services? As we've gone on and we've got multiple implementations and multiple relying parties actually doing this stuff, it's become quite clear to most of us that actually there are a few constraints on the meanings of these things. They're basically locators. So if I submit a registration, I'll get a locator back for the result of that registration. If I want to get a receipt, then I'll get a locator back for that receipt. And it's super important that, for example, that's chosen by the transparency service and not influenced or not chosen by a client and things like that. But essentially, some of the ideas that had been floating around have been in the document about deriving these locators from the content of the object. Those have fallen to the background. They're not as interesting or useful as we thought they would be. So there's some work's going to go on there. Collections of statements, super old, number 9. This has been around for ages. I don't intend to talk too much about this one other than to mention that it's going to come up in the hackathon section, and it's also going to be presented at Cozy. So just hold that thought if you're interested in collections. Then issue signed statement. This is an interesting one. This is a thing that allows constrained devices or otherwise devices that don't have access to an appropriate issuer signing key, which might be held under, given that you can't take these statements back, the issuer signing key is super duper important, and you might want to hold that under dual control or in some confidential compute environment, something like that. And so there's an endpoint in the Scrappy spec for connecting to a transparency service or some endpoint in any case, and having it to do the issuer signing on your behalf. And we've actually implemented and demonstrated this at 120 last time with DigiCert. We're doing that. So I think there's absolutely no dispute that this is a good idea. There's only some question about whether it belongs in Scrappy or whether at least we should enforce that it's kind of a separate environment, because it's certainly definitely useful, but is it a thing the transparency service specifically does? Good question. I think we have Mike Prorock approaching there.
I'd be highly concerned if we didn't define it from an issue standpoint for a variety of reasons, in particular for vendor lock-in reasons, right? When we see the ability and like have definite needs to possibly swap between different signing environments, or for high availability type scenarios where you may have to fail over to a separate vendor for some kind of confidential compute or signing area. If that's not defined as here's how you do this consistently, you wind up having to write all sorts of crazy custom code, and you break a whole lot of the point of interoperability.
Yeah.
So it's not to say that every single transparency service needs to implement it, but if you're gonna implement it, here's how you do it, is a really helpful set of guidance there.
Yeah, that's a great point. Cool, thank you. So the other 3, so interesting ones, but might not result in anything. So there's an issue called hold the transparency service to account. Again, go read the issue, but it's basically talking about consistency proofs and making sure that the TS isn't lying to you or kind of omitting details. The basic thing, in case you're sort of new to this, it's very easy to make an attestation that says, yes, this is good, and another attestation that says, no, this is bad. And then you just selectively hand them out to whoever asks you the question. And being able to check for that kind of thing, or was already mentioned, proof of non-inclusion, all that sort of stuff. This is very important, but it probably doesn't belong in Scrappy. It belongs in the auditor role somewhere else. So useful to pick up, but probably won't actually do anything with that. Support for multiple notaries has been around for a while. This, again, is useful and important from a sort of practical, we're going to market sort of point of view, so that you have sovereign data residency, for example. That's one reason why you might want to do this. Does it have to change Scrappy right now? Probably not. We'll keep looking at it. The issue is not closed, but it's likely that we can actually get this finished without making changes to support that use case. And then there's the request nonce endpoint. This has been in there from the beginning, and it is useful and referenced in other RFCs. We haven't yet found a use or need for it in Scrappy, so it may become a candidate for pruning. But that's it. That's all the things that are open. So it's not, in many ways, not too bad. I think that's, yeah, so I'm going to go on and start the hackathon report before we hand over to Thomas. So any questions, comments, additional thoughts on Scrappy? Good, right. So one comment you might have had is, how easy is it to use? So in going through all those issues and trying to fix up the Scrappy spec, my team discovered, my commercial team in my company team discovered it was really quite mind-bending to implement the spec in full for a very specific reason, that sometimes it would return JSON and sometimes it would return CBOR. And sometimes when it returned JSON, that was because it had failed. And other times it was because, well, it hadn't quite succeeded yet. And it's just messy to deal with error handling and stuff like that. It's not really consistent with the mission of the CBOR cozy family of standards to be mixing and matching and using JSON anyway. So it felt like CBOR all the things was a good idea. So that was my hackathon project for this weekend. And then there was another project. Is he here? Nobuo-san, yeah, he's here. Fantastic. So a newcomer to the SCITT family was verifying that the sort of contents and shapes of SCITT and Scrappy were compliant with or compatible with use cases for software supply chain operations in general, particularly using Yang statements. And then Thomas will talk to us about VCon stuff, which is making a lot of progress. So what we got done: fresh implementation of RFC 9290 in Python, which is nice. Fresh implementation of Scrappy from scratch. So we've had like 3 implementations of Scrappy by now, and for various reasons we sort of throw them away and start again as it gets simpler and more refined. All works end to end, led to a bunch of improvements in the Scrappy spec and some of those issues that you saw. And again, hold that thought for Thomas, integrations with VCon. So quite a lot done. However, if I go back here, one of the big issues that we were looking to achieve is how accessible we can make Scrappy at the same time as converting it away from lovely, friendly English JSON into lovely, concise, and very efficient CBOR. And it was quite hard, actually, to get started. So I did what any self-respecting programmer does when they get stuck. I asked ChatGPT for help. And amazingly, I know this offends some people, but I think it's cool. So I asked for this sort of thing, and it knew what I was talking about. It gave me the spec. It gave me some code. It even gave me a test to make sure the code worked. And it does. It actually worked. So there were a couple of things. It seems allergic to negative numbers for some reason. So all the negative numbers in CBOR tags were, if I go back again, were all positive. But that's easy to fix, right? And all past the validators. So having this success, I went back to a different problem that Steve had been having for one of the Friday drafts for specifying MetaMap header. And we'd all sat around for quite a long time trying to work this out, pasted into cbor.me and whatever the other one was, I can't remember. And it just said no. And you posted another one, it said no, validation failed. Ask ChatGPT, how do you turn this JSON into CBOR? I said, there you go. And paste that into CBOR.me, it was fine, and it works. So, so what does this tell us? Oh, hang on. I'm going to do these in a slightly different order. So what does this tell us? It tells us that the CBOR specs and the COSI specs are actually good. Because if ChatGPT knows them and it works and it outputs working code, clearly the specs are very detailed, correct, and accurate. Which confirms that doing the work to make Scrappy consistent and all CBOR, getting rid of the partial JSON responses is a good idea and it's smart. We're going to keep on with that. So as a sort of, I don't know, this is an appeal slide really, just to say we found pockets of tooling and libraries and parsers and things around the internet. So the code also exists, but it doesn't seem to be very easy to debug CBOR. And if we're looking to go into a mature deployment adoption phase, we need to have things that in your VS Code will just say, no, that's broken, or you run a thing and it can convert your binary straight into EDN or CDDL or something, just to make it easier, more accessible. So if there's another hackathon on this, it will probably be a tooling hackathon. But there you go. The other thing, speaking on behalf of Nobuo-san from Sokendai, is he was looking to apply Yang statements, RFC 9472, for things like VEXs and SBOMs, to see if that mapped to the concepts and then the processes and the API for SCITT. And you know, we didn't have very long. It's only a short weekend, but the summary of that was, yeah, seems to work. Nothing missing, and seems to cover all the use cases. So those two together says Scrappy seems to be on the right track. We just need some more implementations to test it, a bit more developer friendliness maybe, but we're basically there. So as a setup, I don't know if Thomas is here, if you begin to approach the mic. Just remembering again from 120, one of the things that I think this is the only conclusion actually that came out was this ability to discover or link statements, as Steve was explaining earlier. We came up with a proposal for that, and there's a little nugget of that being used in this example. So this thing that we came up with and proposed last time is kind of vital to what Thomas is about to speak about working. So this is again good progression.
Thomas Howe, Stralid. So I'm involved with the VCon working group, and we are working on using the VCon use cases as being a place to test Scrappy. And so as we came to this last at 120, we were asking the question, what would be the right intersections between the VCons and the VCon lifecycle and Scrappy? And as we began to look at identifying and interacting with the ledger, we realized that there is an opportunity for us to do a bit better on that, because the VCon lifecycle has a little bit of a different flavor than set and forget. It's more than just one statement. So go that way.
Yeah.
Yes. Okay, great. So so here's the context. The intersection, the reason why Scrappy and SCITT as a larger idea is important to us at VCon is it allows us to provide this sort of security and transparency that we need for the conversations that the VCon container contains. And so when you think about virtual conversations, specifically in respect to privacy and compliance and governance, we realize that a VCon isn't a static element. A VCon can move around the network and be added over time. So things that need to be put on the ledger for auditors and for developers are things like the creation of a VCon, a change of who owns it, maybe when it's redacted, or when we have a change in the consent for purpose, consent for purpose revocation. One quick item on that, a long time ago when we were collecting consent for recording, it was simply a consent. Now it's a much more nuanced idea. It's not simply consent, but it's consent for purpose. and it's consent for a purpose that can be revoked. So it becomes a much more dynamic idea. So you can see right here we have a nice little diagram of that where two people are talking and that results in a beacon that's been created. That creation is put on the SCITT ledger. And so as time goes on, as that beacon is processed or its consent is revoked, all of these things here are put on the ledger such that the customers can enforce their right to know about what they know about your data. So I want to know my data, and I want to know what happened to it. Same way with compliance audits. And so we wanted to demonstrate the ability of Scrappy not only to be able to handle a single event, but a list of events. And then going back to the original, being able to find statements based upon the ID. For us, it's going to be the beacon ID or the issuer, which is generally the person who made the beacon in the first place. This makes this really practical for us. And so as we begin to really vet out Scrappy as being something appropriate for clients that need to put stuff up there, it's working out pretty good. So just as a quick thing, what does it actually look like? So you'll see right here, we have our SCITT signed statement. And down in the protected header, you'll see here that down here, you'll see that we have not only the beacon operation inside the protected header, we also have two new CWT claims. The issuer, Z Telco, which is one of the beacon participants, is the one who made the beacon, and that subject is the ID of the beacon. So that allows us to have some very nice scalable systems and for this working group to prove that Scrappy works pretty well for what we need. Thanks everyone who is here with us at the hackathon. It's one of my favorite parts of IETF, the interactions and the real thing. So thanks John, Stephen, Robert, Cedric, Roy, Thomas, and Niburo. Welcome to the team. Thank you.
Thanks, Thomas. So I see you're doing the poll.
I'm getting ready. So we have a couple of questions that we'd like to ask, and I'm going to do a poll for the first one. So as Hannes kindly mentioned at the mic, I think there's been a pretty good set of interaction in the working group as the architecture draft has progressed. And so we'd just like to take a quick poll to see if anyone in the working group doesn't believe that the architecture draft is ready for working group last call. So I'll give folks a few minutes. If you'd like to come up to the mic and make any comments about it, this is your chance to do that as well. All right, we're really trickling at this point, so I'm going to end it, but you can see the numbers, 15 for yes, and other than that, no opinions. There's no one who dissents. So we do intend to move it to working group last call. We anticipate, if you haven't read it yet, this is a great chance to do so. We think the document is quite stable and ready to progress, but we absolutely would like to have as many reviews as we can, even though we think we've had good participation. So we will thank you for that.
Yep, thank you. So the other question that we always ask at this point in a IETF meeting is what the group wants to do about interims. So last time we agreed to try the GitHub process, and seems from the chair's point of view and from the progress that the GitHub process worked well. I think special thanks to AJ for setting up the repeater for the mailing list. I think it's a really fantastic thing and gives the right visibility. So would propose, I guess, to keep on that track, and unless anybody really feels like there are reasons to have specific planned interims. Otherwise, we'll do those as the working group last call, or any reviews on Scrappy necessitate such a thing. So, any comments on interims before Bangkok? Looks good. Thank you. Oh, should just check the chat just in case. Yep, no, looks good. Okay, thank you. So that was both the chair questions. So I think we're good for. Well, this is, yeah. So we're asking for working group last call. That'll happen. There you go. AOB. So any AOBs, open mics? That's a sign of a stable working group. Well, thank you very much.
Get some a little bit of time back.
Yep. So let's get some time back. Thanks. Yeah, good. The last minute flurry on the chat worried me. I thought somebody was about to come up to the desk, but no. Cool. Okay. Thanks, everybody.
Enjoy the rest of your IETF. What? I'm happy to see the cameras back.
Did it ever go away? I thought the camera's always here, isn't it?
No, I feel like there's a couple. You made a couple of trips without bringing it, didn't you?
The room.
I'm like super both concerned and intrigued by this automatic converter. Sorry.
Yeah, well, no, it's this here. I've got it.
Oh yeah. Like, I'm super intrigued, but still concerned that like they built this converter and here it is. Like